Be going over the production function. The production function just measures how much product, how much can we produce with just the amount of labor or inputs. So what we can produce based on how much labor we have. This is the general function. It's kind of like a hill. Increases, increases, increases. Then there's a peak and then it slowly decreases. It's kind of like a hill. So today we're going to be learning like why is it shaped like that, what does it show, and how we can actually answer problems regarding the production function. So why does it look like that? Well, it's because of the diminishing marginal returns. It's the idea that the more and more workers you have less and less marginal benefits. So I just like to explain this using like moving an apartment because I feel like most people have moved either sometime in their life from a house or an apartment. So let's just imagine we're moving an apartment and we have a variable amount of labor. So let's say we have zero labor. Well, nothing's going to be done. It's zero product. We're not going to do anything. But then one person, let's just say you are moving the apartment, you are moving it out of the house. Well, you'll be able to do stuff, but it's going to take a long, long time. You're going to have to pack everything. You're going to have to carrying everything, getting tape. It's a lot of work. Two people, that's even better. That means it's getting a bit faster. You have more people. You have more manpower. 3, 4, 5 people, that's really good. It's starting to amping up. You got to do stuff real fast. Maybe 6 or 7 people are the ideal amount. Maybe that's the ideal amount of people you have based on how big your apartment or house is. But then let's just say we keep adding and adding people, right? Let's say there's like 12 people, 20 people, 30 people. Well, it's starting to get a little packed. What originally turned as a moving an apartment becomes almost like a party. It's so crowded. People aren't doing their job. It's not great. And this actually happens in the real world. That's diminishing marginal returns. We saw that with a few inputs, you can get some productivity or some total product, but it's not really that great. There's an ideal amount of labor or an ideal amount of inputs that gives us an ideal or the maximum amount of product. But if we add too much input, so we have too many people, then it slowly starts to get less and less productive. That's the idea of diminishing marginal returns. Why does this happen? Well, we have a limited amount of capital. What does that mean? Well, we have a limited amount of stuff we can actually like box. We have a limited amount of boxes, limited amount of tape, limited amount of tools we can actually use to move people, right? So if we have too many people, well, they can't use those tools. They can't use all those capital, so they're not that productive. That's why we see this kind of hill-like shape here. So then what's this graph? Well, this graph is measuring what calculus students would call the derivative or the differential equation function. But for now, just think of it kind of like slope. So we see in the first, we divide it up into 3 stages as we see here. First, second, and third. In the first stage, we see that product is increasing and marginal product is also increasing. So that means the slope is slowly getting up and up and up. It's steeper. It's kind of like a mountain almost. And we see here on the derivative function that the marginal product is increasing. So that creates almost like an exponential type shape, kind of something kind of hilly, kind of steep. Then we enter the second stage. The second stage is where we're still positive, right? Productivity is still increasing. We're still getting more productive, but it's going at a slower rate, slowing down until we hit some maximum point. That's because marginal product is slowly decreasing. It's slowly decreasing until it reaches 0. Then the peak of productivity, so this peak right here, our maximum or our optimal point, is when marginal product is 0. From there, stage 3 is when total product is negative and marginal product is marginal product is negative, total product is decreasing. So those are our 3 stages. And then you're going to see a lot of times that it's shown through a graph. So let's actually graph it. So not a graph, a chart. So we see the total product of pizzas. 1 worker 10, 2 workers 25, 3 workers 45. We see with the marginal product 10, 15, 20. The difference between them. 25 minus 10 is 15. 45 minus 25 is 20. So that's the marginal product, is the change in total product. we see that it's increasing, so we know this is the first stage, so it's a green. Then let's go to yellow. 45 to 60, that's 15. 60 to 70, 10. 70 to 75, 5. 75, 75, 0. So here we see marginal product is decreasing. It's still positive, but it's decreasing from this point, 20. So that's how we know it's the second stage. Things are slowing down. And then the at 8 workers, right, we go from 75 down to 70. So our marginal product is a -5 because that's the change. And then we know this is the third stage because total product is decreasing and marginal product is negative. So those are how we indicate our 3 stages of the production function. So here's 2 different problems. Pause the video and try to solve them. Okay, let's go over these. First question, in the short run, a firm's production function initially exhibits increasing marginal returns and later diminishing marginal returns. Which of the following best explains why diminishing marginal returns occurs? So you have to remember the main reason this even happens, why we actually have this hill shape, why it's slowly decreasing, why isn't it exponential, right? Well, it's because of the limited capital. Because of limited capital, all our workers can't be productive. Let's say we worked at a big Amazon warehouse where we had like infinite amount of machinery. We had all those different things that Amazon workers use. I don't know. Well, then there would be no diminishing marginal returns because everyone would be productive. So instead of this hill shape, we would have an exponential function. But when we're moving an apartment or when in any real world situation, because of scarcity, we have a limited amount of capital. So every worker can't be productive. So based on that, what would be the answer? Well, it can't be A. Labor becomes more productive as more workers are hired. That can't be true. Because if that was true, we would have an exponential production function. And that just doesn't make sense. It can't be C. Firms face rising average total costs in the long run. That can't be true. The law of supply causes total product to fall. That's against the law of supply. So not only is that just incorrect, but it doesn't make sense in this problem. So we get our answer as B. Fixed inputs become less effective as more variable inputs are added. And this makes sense. We have a limited amount of capital, our fixed inputs, so they become less and less effective. When we're moving apartments, let's say there's like 100 people, right? Well, now we only have like we still have 1 or 2 tape dispensers, so it becomes a huge crowded line. So because of that limited capital, but a huge amount of variable inputs, we see that it's less and less productive. So the answer would be B. Then the second question, the table below shows a firm's short-run production data. At which level of labor input does the marginal product of labor begin to diminish? So this is always a confusing question to people. They're always confused. What do I say? What units? What is correct here? You have to notice what it's actually saying. Marginal product diminishes. So it's not telling you total product. You have to calculate marginal product. So what's the marginal product of 1? Well, we have to find a change in total product. So the marginal product here would be 15. Here it would be 25 because 40 minus 15 is 25. Here it would be 20, then 10 because 70 minus 60 is 10. 75 minus 70 is 5, so here it's 5. So that's our marginal product. So when does marginal product begin to diminish? Well, here's 15, here's 25, and here's 20. Well, we see it has to be between 2 and 3 because 25 just decreased to 20. So we get our answer as B. So that's everything dealing with the production function. You have to understand like why is it this hill shape? And then you have to understand what stage are we specifically in. And you have to determine how we can calculate that based on the graph and on the chart. If you get those, you basically understand the production function.